Alright, another draft physics video presentation. DraftScience here on YouTube. So anyway, one comment. Yes, commenters have learned there's no rewards here for commenting, really, if you can't say something about physics, and people just can't make a physics argument, so they're really not useful. I mean, there's just no point in saying, oh, I like your videos, because, that's sort of useless. Or I hate your videos, that's sort of useless. And so unless you can make some sort of physics argument, it's all quite useless. So I guess I ought to just kill the comments, but there is still hope. So we'll just see what happens. Well, anyway, somebody who deserves to be, recognized for his excellent work on the internet. Random Dumb. Random Dumb. Yeah, so it's the right name anyway. Looks like he's wearing some sort of Muslim hat or something, but no, he's just bald and he's got a bad background. But anyway, but just such a fucking stupid comment, And so just for the future, okay, this is one of the people, like, embarrass him thoroughly, for the rest of his life, because really, it's just this kind of behavior should be, people should get what they deserve. Okay, and you deserve something when you just talk shit on the internet. It just turns the whole internet into a piece of crap. Here we have this insanely brilliant way to organize, really optimize human communication, intelligence, ideas, structures, all of this power we have. And it's being squandered by all these assholes. You were just letting them turn it into a shithole. Okay, anyway. I don't understand it, so it's wrong. So he couldn't even put a little bit of punctuation in there to make it readable, and then put it in quotes as if that's what I'm saying. Wow, you are something. An idiot, perhaps, question mark. So he got his punctuation right there. Well, brilliant comment. You sure deconstructed the whole theory there, didn't you? And so this is on the Feynman videos, where I'm pointing out how, clearly it's not that I don't understand, and I do understand what Feynman's saying, and I'm dissecting it for you and showing you just how it's made out of absolutely nothing. And so I'll do some more of that since you brought up the subject. So that'll be half of your reward. And the other half will be, I'll just show your channel, which is crap. Okay, I mean, just absolute crap. Dancing with a cat on my head. iMovie from iPhone. I mean, just stupid, buffoon, moron crap. Putting film in a 30-year-old, 40-year-old camera. I mean, I had one of those when I was like 15. I bought one, when I was 15. With money I had earned. Delivering newspapers. Over $100 back then. Anyway, but I mean, just useless video. So we'll play this little bit just so you're immortalized, properly, and so your family can all look at this and say, oh, what an asshole. God damn, I'm related to this fucktard. So whatever it has, here's some Russian talk. So apparently he went to an interesting place, and this is the best video he got from the interesting place. So they're dudes, real dudes. Grown-ups. So just, can you get any more moron, right? So they're doing asshole, hey, what's the stupidest thing you can think of we could do? Let's do that. And then we'll show each other our bruises and such. So anyway, not much to say. So this is people who feel empowered to comment about other people on the internet. I mean, this. Yeah, this. Thinks they have the authority, that they've properly understood themselves anything at all about being alive on planet Earth. Like they know what their brain is, and what it's capable of. And what potential it has. Now, clearly they don't care. So anyway, you've gotten your 15 minutes of fame this way, fella. So bravo. Yeah. In a very negative way. So some other asshole posted a comment to this, linking to this video of Feynman, and then they removed the comment. So I don't know whether they were saying, oh look, this is Feynman talking about pseudoscience, or whether this is a perfect example of just how clueless Feynman was. So let's play it just for fun. Right? Yeah.
Because of the success of science, there is a kind of...
The success of science. We don't know what it would have been without you people in the way, frankly. What it could have done if it actually got the right answers. You know, if it put plus and minus in the right place. You know, if they fixed that right when they figured out it was wrong, like 230 years ago, you know, how much of a difference it would have made. How much more coherent their physics would have been. And if they would have actually explained things honestly, instead of just convoluting them with all this mush talk. Like I'll just illustrate just, you know, Feynman's whole series of lectures he gave, you know, the 5 hours worth of lecture anyway, you know, in Auckland. You know, the whole wheel turning thing is, you know, when you dissect it, I mean, it's so simple what he's really talking about. And it's just, I mean, he was a horrible teacher in the sense that he made something terribly simple complicated and then pretended he simplified it.
I think a kind of pseudoscience, that social science is an example of a science which is not a science.
I would say theoretical physics is an example of a science. It's not a science. You don't care about repeating any experiments. You don't care about even proving anything at all. And you'll jump to any conclusion possible. You'll conform the evidence. You'll force the evidence to fit, which is a perfect example in the two-slit experiment. You'll just lie about what the experimental results actually are. You'll glorify or you know, excessively exaggerate the simplicity of the experiment and pretend, oh, a beam splitter splits light in two, and this does that, and, you know, and it's all bullshit. You'll say, oh, the same thing happens with electrons, and the whole experiment is completely different. I mean, you know, it's full of just lies and distortions and exaggerations. You're terrible scientists.
They don't do scientific. They follow the forms. You gather data, you do so and so forth. But
yeah, it's too bad you don't do that. It's too bad you don't get anything called real facts, right? So you talk about detector experiments that you knew were theoretically impossible to do. I mean, he's not stupid, right? I'm not supposed to believe that Richard Feynman didn't know, no, there's no way you can detect. I mean, maybe he did because he thought photons were created by electrons, that a single electron creates a photon. I mean, he believed that. So maybe he believed you could shine light on electrons and create a electron shadow or something, and somehow you could detect its existence. Maybe. But again, he knew the photon had way too much energy for the electron to survive the interaction. So he knew it wasn't possible to detect them, and yet he talked about it as if they'd done it.
they don't get any laws. Haven't found out anything.
And again, laws are of only so much value because you have to recognize that, guess what? Electrons and protons aren't bowling balls, okay? And certainly, even bowling balls aren't bowling balls. They're made of atoms. I mean, the fact is you're the people who seem very clueless in recognizing that this whole idea of a law isn't what you're seeking. You're not seeking some universal statement about things that are completely different. Like making some statement about living things when there's really substantially two forms of life, right? The stuff that is single cell operated and the stuff that has colonies of cells. And those two things aren't really anything alike. It's like saying a brick is the same as a building.
They haven't gone anywhere yet. Maybe someday they will, but it's not very well developed. But what happened?
Blah, 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 blah. He says he makes statements and then just qualifies them into zero. Well, maybe they're full of shit, or maybe they're not.
Is at an even more mundane level, we get experts on everything that sound like this.
Right, right. And what are you? Just another one of these people pretending to be an expert, all right, when you know, he's done nothing experimentally. He even conceded, you know, in the Auckland thing, he doesn't have any experience with photomultipliers. He just knows about them. He knows they exist. He never handled one, never controlled one, never played with something so fundamental to his own physics.
Sort of scientific expert. They're not scientific. They sit at a typewriter and they make up something like.
Yeah, exactly. You sit at a drawing board and make up silly little diagrams, and then you contrive some silly, you know, I don't know. I don't even know how to describe it. It's so silly. You know, a way of calculating probability when all you're really calculating is phase.
Food grown with fertilizer that's organic is better for you than food grown with fertilizer that's inorganic. May be true, may not be true, but
Yeah, well, it may not be true if the organic fertilizer is bird shit and it's full of 15 million viruses. It'll kill you. Yeah, it may not be true then.
it hasn't been demonstrated one way or the other. But they'll sit there on the typewriter and make up all this stuff as if it's science, and then become an expert on foods, organic foods, and so on. There's all kinds of myths and pseudoscience all over the place.
Yeah, they may be right though. I think he's going to say that.
Now, I might be quite wrong. Maybe they do know all this thing.
Yes. What's the point? What's the point of your statement? And so again, you know, there's no name calling. So why don't you find the ones you're talking about and point them out and say, well, Dr. So and so making his commercials or something else. You know, because they're not all the same. Everybody who opines on a subject isn't everybody. They're not all the same thing. Again, physicists should know that.
But I don't think I'm wrong. See, I have the advantage
Right, sure. So I don't think I'm wrong.
of having found out how hard it is to get to really know something. How carefully.
So again, he claims he doesn't really know. So that's the big joke. I don't like it. I don't know. Too bad. Shut up and calculate. You know.
You have to be about checking the experiments.
All right. So there's absolutely no evidence that he checked any experiments. I mean, again, the Young experiment was wrong when Young drew it. Okay, he drew two waves coming out of two slits. It was wrong. It would get the wrong answer. The only way it can get the right answer is if they make the slits so infinitesimally small that they have no effect on the experiment, in the sense the distance becomes so minor and tiny that it can't create a visible effect. And that's the only case in which their theory is right. A case where nobody ever accomplishes, really, because the slit would have to be narrower than a wavelength of light, which they can't even make anyway, realistically. So this is all such a lie. The whole thing is just such a pile of shit propaganda. So he paid no attention to the actual experiment. He never did it. He never calculated anything. He never even questioned any of the crap somebody told him.
How easy it is to make mistakes and fool yourself.
Right, exactly. Now that's a lesson he probably has learned. He's probably gone on even more bizarre tangents and figured out, oh, that doesn't work. But he still gets away with a big ton of silly assumptions based on pitiful analysis of any details or facts. I mean, how much does he know about the Eddington experiment? How much does he know about the experiments that are claiming light is bent by gravity?
I know what it means to know something.
Yeah, no you don't.
And therefore, I see how they get their information. And I can't believe that they know it. They haven't done the work necessary, haven't done the...
So it's just so ironic for him to be criticizing people who haven't done what they need to do, which is the detailed analysis. Again, they could figure it out in 10 minutes that the double slit with two waves can't work. It won't accurately describe what happens. because what happens depends on those four sources, and without the four sources, you're not going to be able to get anywhere close to the right pattern. Two waves won't do it.
Checks necessary, and then the care necessary.
Amazing. All right, so he doesn't care about, well, detector smector. I can imply we did detector experiments when we didn't do them. You know, he doesn't care about the fact that, well, if the real analysis says you really have to narrow this to the surfaces, because the surfaces are in fact the point sources. So whether you think it's waves or you think it's something else, it doesn't really matter. You have to put your wave right on the surface, because that's the place where the math works. It's really a surface experiment. The single slit is the two surface experiment, the single impediment is the two surface experiment, and the two slit experiment is the four surface experiment.
I have a great suspicion that they don't know that this stuff is, don't know, and they're in.
So, and you know, and this is the guy famous for the video where he's explaining magnetism without explaining anything. You know, with explaining how old ladies fall on ice.
Intimidating people, but I think so. I don't know the world.
Yeah, you don't think you intimidated anybody. You don't think you have used your authority to smooth over a bunch of morons and convince them that, yeah, you people know what the fuck you're talking about, when you really don't.
Very well. That's what I think.
Yeah, unimpressed, sorry. Hypocrisy, and duplicity, and bullshit. So, okay, so you got whatever you wanted, I guess. You post the link. Again, it was another unannotated link, you know, just, okay, go, you know, here's a link. Like, somehow it's going to say something that means something. Well, who did this mean something to? You know, again, Feynman, interesting character. Would have liked to have known him, all of that kind of crap. Don't think he's evil or nasty or horrible. But it's just a good example of exactly where this whole ego thing leads, and how it all just becomes cultural physics. It has nothing to do with the facts of the truth. It just has to do with selling, you know, magic to the moron public. All right, so in that vein, leave us go to the drawing board. All right, so in Feynman's lectures, in the second set at Auckland, New Zealand. So, I mean, really, some of these videos are not for the general public. But anyway, he uses so people are familiar with the video, he uses a turning clock. That's not exactly where the camera is. Okay. The hand's on a clock, and you spin the hands around. And this is a way of figuring out why there's going to be a reflection off of a surface, let's say. You have two surfaces of the glass, a layer and then another layer, and then you know that some of the light's going to go from this other surface. And so if you want to calculate what the probability, okay, that you're going to get an actual photon here, you do it by this clock method. And all the clock is doing is, we're back to sort of the wave model, but it doesn't really matter. I mean, obviously a sine wave, you know, is made of two portions, and if you put those two portions together, you got a circle. All right, so that's really all he's doing here. So the circle is just representing phase, and this would be 180. You know, this would be technically 90 degrees of the sine wave, but it doesn't really matter. This would be out of phase. Okay, so this is out of phase. This would be 100% in phase. And obviously all the other points on the clock would be some degree of phase brokenness or imperfection. And so all the distance, all the clock is really doing is as you're going down, your time is ticking, time, and then when you go through a medium, it slows down. Okay, so the time is, you have to compensate for the change in the amount of time, and this is just has to do with, so you're just going to add up a vector from this surface, and then you're going to add up a vector from this surface, and you're really just going to say the more in phase they are, right? So the more the first arrow is this way, And what you really want is for the second arrow to be in the same exact direction, because then they're in phase, and then you'll have 100% of your area will be, okay, in phase. So you'll have 100% probability of getting a photon because you're in phase. And any other arrow for the second arrow is just telling you how much out of phase it is. All right, so it's, that's all it's going to tell you, and that's going to change your probability. And obviously this angle would be the same as this angle. So if I was going to add those two arrows, right, in the famous Feynman way, if I want to add an arrow here, and I'm going to put another arrow for the other one, and I'm going to take that arrow, right, and I'm going to move it to the head, it wouldn't matter whether I was going that way or I went this way. The hypotenuse, okay, the new line I'm going to draw, okay, that's going to establish my square, my area. I mean, he's using circles, but you could just use squares just as well. It's just Pythagorean math. Will tell me my probability out of a whole, the whole big square, if the continuous line. And it'll tell me what percentage of I'm going to have of having the light, right? But you can understand that 3 o'clock is going to be the same as whatever o'clock. 3 o'clock is going to be the same as 9 o'clock, in the same amount of probability. So you're just saying how broken is the photon. This would be 100% broken, and everything in here would be this would be 50% broken and 50% broken over here. And that's all it's doing. It's just doing a phase analysis by making a stupid clock. It's just making it more complicated when you can just draw the vectors. You could just draw the lines, and you could just say how much time, okay, time, a certain amount of time, and you just divide the frequency into that amount, the time used, and that'll tell you what a phase is. And then you're just saying the second line, okay, well, it goes through a medium, that means more time, so I add a little extra length to that line for the extra time, and I figure out, does this go in as a whole number into this? And if it doesn't, then I have a remainder of some kind, and I know it's out of phase by some amount, and that amount could easily just be converted into a probability potential. So it's just ironic that all these people who have all this respect for math and, oh, it's such a great thing and math saves the world and blah, 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 Feynman's almost mocking it by turning what is really simple, explicit math. I mean, you know exactly what you're doing. You're just measuring distance, okay? And you're just measuring, it's a blinking light, right? It's blinking on and off, on, off, on, off, on, off. And all you're trying to do is to say, well, what's the cycle? I mean, this one landed on an off. Is this one going to land on an off? And that's all you're saying. Is this extra distance, this extra blinking time, mean that it blinked on or did it blink off? Is it in phase or out of phase? And again, the phase argument just has to do with the fact that you're reconstructing photons. So the surface, the light breaks on the surface. Some of it breaks off. It gets hit by little crap. It breaks off, and some of it scatters and leaves. And the fact is when you hit the second surface, you're going to do the same thing. And all you're really asking, the question is this bit and this bit, are they going to reconstruct, okay, this kind of event? Are they going to reconstruct a frequency that's, if the light's 500 nanometers, that returns it to a 500 nanometer frequency? And that's it. Is it here versus here? And that makes a difference. You can't receive it if it's out of phase. Well, just a little bit out of camera range there. That's a little disappointing. But anyway, you get the point, I think. So the whole confusing clock, spin the clock round, 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 all of that crap just to say in phase, out of phase. Just to say, here's your vectors from two slits, I mean, how much longer is this line than this line? If I put notches for the frequency, do they match? Do the notches end up matching at that surface? That's it. So all of that complex crap to just do this again. And again, even the wave mechanics here, you can see right here, I don't need any wave mechanics. I don't need two waves to interfere with each other in space here somewhere, for photons to crash into each other here. All I have to do is measure this distance. And that answers the question, is it possible to put pieces together? Yes, it's possible to put pieces together here because there's a full wavelength of difference in these two distances. It's not a half wavelength. If it's a half wavelength, then I'm going to turn 500 nanometer light into 200 nanometer light. Yeah. But you can't do that for physical reasons, because the polarization, you won't be able to make 200 nanometer polarization out of 500 nanometer light. It's going to be too spread apart, so it'll never be received as 200 nanometer light, because the polarization won't be right. But it just has to do with a timed event that happens to electrons. The simple principle is electrons need to be hit twice. Okay, you got to hit them once to get them on their way, from a locked position inside of an atom, and then you need to hit them a second time to free them. And when I say hit them, I'm really just saying you need to hit an atom that has electrons moving from atom to atom, and you have to just hit that again to cause enough energy to knock that electron free. And that's when we say, oh yes, that's a photon. Simple principle. They've just turned it into a complex bit of mush. I mean, Feynman is sitting here. Maybe I'll pause to clean the board and go to the other subject, just throw in some more stuff. Yeah, so I'll pause now because I don't remember what I was going to say anyway. So I'll be back. Alright, should be back. So yeah, I wanted to say something about Feynman and just the fact that, okay, he's selling the idea that there's a random God that's forcing this to happen, when, again, how is it random when you know the point sources are the surfaces? That's the only math that works. So you know that there's a difference between a photon that goes through the center of the slit and a photon that goes next to the surface. There's a difference. They're not all doing the same thing. The same random God isn't controlling their destiny. So, right there, that's done. That just isn't a viable explanation that, something random happens because the random God says so. And then he uses math that's just it's just a modification to the same wave math, phase math. And then even the idea that phase has to be about waves, when phase just about anything that has a frequency to it. Anything that has a cycle, a repeating frequency. Anything like a pendulum swinging. Why does that have to be seen as a wave? It's not waving. Anyway. Alright. So, the related subject is this whole idea of what happens to atoms and what electricity is and all of that kind of crap. So I just thought I'd go over some of that in the sense that the photon, so this is a row of atoms on a surface. The idea is that the energy hits an atom. There's a certain amount of time it takes for that energy to be transferred to the next atom and to the next atom to the next atom. And the idea is the second photon, the second element of a frequency, and this would be represented by the polarization. So that you have two elements. You have the idea of the frequency, and you have the idea of the polarization. And those two things are proportional. And the reason why they are is because of this fact, is that an element of a photon hits this atom. The next element, the next piece of rain, is going to hit forward of that at the same rate at which this is moving, which means it's going to hit and give this electron, right? This one was just going to get a boost from this atom, and that was it. So it was going to get one portion of energy going this way. But this second one hits, and that gives it a second portion of energy, and that's what causes the photoelectric effect. And in the case of electricity, it causes an electric current. When the electron doesn't leave, it means you're going to cause a current of electricity in the atoms. that we'll be able to detect. And that's how we detect a photon, is essentially a piece of energy hits and another piece of energy hits at the right frequency, at the right time, at another location. Okay, so it's about time and location. So it hits at the right time and at the right location, and that will create what we detect as a photon. And so taking that a step further, getting to electricity and magnetism, so I could argue that what happens in a conductor, right, so this would be the way I would explain electricity, or something like this anyway. Obviously I haven't had hundreds of years to develop a lesson plan and to, you know, detail all of this stuff, but if I was going to re-explain it to my younger self, it would have made so much more sense if they would have explained it this way, that, you know, materials like conductors are full of atoms, and you know, what you're going to do is this idea of this extra electron or this less electron. You're either going to pull electrons out, or you're going to push electrons in. And the idea is you're going to push them in with a speed. So you can, if I push them in very fast, okay, if I, you know, jolt really hard, then that transfer will just be between this atom and this atom and this atom, and they'll just transfer the jolt. Okay, and so that would be high voltage. Okay, so you only need a couple of atoms to do that to get a pretty strong wattage at the end, right? And that's what you're after, is how much watts. And in between there is just amps. And amps, you know, it starts with an A. You can think of it as meaning atoms, because really it's going to tell you how many atoms you're involving. Amperage is just telling you how many atoms did I have to involve in the process to get a certain amount of watts to the other side. And the fact is, if I lower the voltage, so I go with a low voltage, like 12 volts, versus 120 volts, then I'm going to have to put this to get the amount of pressure, which is a certain pounds per square inch you're talking about coming out at the end. I'm going to need to involve a lot of streams of pokes. I'm going to have to hit it a lot of times with this 12 volt stuff to get the same amount of push at the other end. So I'm going to have a lot of little pushes. And the little pushes will all have to have a pathway through the conductor, and so they're all going to involve more atoms. And that's why you use a low voltage, okay, at a high wattage, that is a lot of a lot of pushes, to involve as many atoms as possible if you want to try to make it magnetic, if you want to try to make the effect. So the idea is that when the electron is being exchanged between the atoms change their shape and they become polarized. So you could sort of understand that as it's going up, as the electricity travels, the extra electron, it's going to, the state of the atoms will have to be, you know, it goes like this one goes fat and this one exchanges, so this one goes fat and this one goes back to normal, then this one goes fat. So the extra electron travels like a little wave, like a hump of water, but it's not waving clearly. And it becomes polarized as that happens. It becomes a little magnet. It becomes a dipole. And obviously the dipoles would tend to be in some sort of arrangement because the electricity is all moving in one direction, and the expansion, you know, the polarization of the atoms is all in one direction too, and it obviously would be perpendicular to that. I should draw it up here. Perpendicular to that would make sense, that the north and south would end up being perpendicular to the flow of the electricity. And so these atoms are all becoming polarized, and in 3 dimensions you could sort of understand in a conductor that means the polarization is going to be in, you know, this outward direction, and so it's going to basically be creating on-offs traveling north south north south north south, traveling down the conductor. Okay, so that would be the effect, is that you're going to create this polarization, and you know, one side of the conductor is going to go south north south north south north, and the other one side is going to be north south, north south, north south, but it's radial. So it's all, both sides are producing the same amount. It's just that one side has a pattern that's the opposite of the other side's pattern of arrangement of north south. But the point I really wanted to get across is that the lower voltage means you'll polarize more atoms. That is, you'll be changing the shape of more atoms. Okay, and and the change in the shape is what makes them magnetic. And that's what's so so being magnetic just means that they're going to interact with the field energy that comes into them. They're going to be a filter now, and now they're going to convert gravity into magnetism. They're going to create gravity into a pattern of north south, or plus minus, on and on. But the idea is that amperage means the number of atoms, and voltage just means how much you polarize the atom. So it really doesn't matter whether I polarize the atom big or I polarize the atom small. The polarization is the only part that matters. So the higher voltage doesn't get you anything in terms of, first, it involves too few atoms, so you don't make much of a filter, and the change in the shape of the atom isn't more dramatic. I mean, it's more dramatic to the atom, but it doesn't make it more magnetic. So with 12 volts, you can do all you need to do, which is change the shape of the atom and polarize it. And if you use the low voltage, then you can pump more wattage through the wire and affect more atoms. And that's what you really want to do, is affect as many atoms as possible in the wire to create as much magnetism as you can in the wire, if that's your ambition. And that would be deciding that kind of thing. Screensaver. Anyway, so yeah, I just thought I'd throw that in as a little bonus. So this idea of fundamentally the argument is that a magnet is just a filter, and just like a proton and electron would be. So if you can understand that there's a real force in the universe affecting electrons and protons, and you could understand that if I put an electron and proton really close to each other, that whatever the electron is reflecting, whatever force is reflecting off the electron, the idea is that the I guess I should do the two color thing, but I don't know where I put my colored chalk. Well, it's probably in this little cup. Yes, it is. All right. So the idea would be is there's two kinds of force to go with the two kinds of charges that exist in the reality, and that the two kinds of forces have an inverse reaction. That is, the red force reflects off of protons, and the blue force would reflect off of the negative charge. And the consequences is that when the opposite color, say if this one, if a pink was going for a blue, it would just change its direction. And likewise, if a blue hit a pink, it would just change its direction, and the object wouldn't gain any momentum. So this causes momentum. That is, the blue force reflects, but first it moves the electron. It sticks to it and keeps going with it until it gets hit by an opposite force, blah, blah, blah. I've been over some of this stuff in other videos. So the basic diagram of what a magnet's doing, you can understand. It's taking a bunch of mixed force from the world, what would be gravity, and a bunch of the same stuff that makes photons, except it doesn't have a consistent frequency. And it's really just going to sit there by just its nature of a dipole. It's going to end up reflecting more blue this way and more red this way. And depending on how many of these little magnets there are in the substance, these charges, a magnet would just be a bunch of these. Now they're in domains, which implies, some sort of organization, where the little magnets are actually inside of something called a domain. And so inside of that there are little magnets, inside of that, and then so you can change the direction of the little magnets inside the domain, and then you can change the position of the domains. So there's lots of room for a little bit of a complexity in this simple diagram of in and out. There would be a mixture and a pattern. So there would be a pattern, a specific pattern that comes out of the when you do it as a magnet, as a atomic. When you're making it out of atomic dipoles, the simple, what the charge would do becomes a little more complicated, because you have different atoms and different arrangements, and like I said, they're you know, the magnet isn't doing anything electrical to create the phenomenon. It's just interacting, just like charges would, on the atomic level. But on the bigger level, it's going to look a little different. So all you're really doing is saying, is it the pattern red, blue, red, blue, red, blue, or is it blue, red, blue, red, blue, red? And that makes the difference between the two poles. But anyway, simple explanation, mechanical, no woo, no virtual photons, no superpositions, no anything, no magical energy from no force. I mean, you know, everybody has to have wondered, I mean, where does the energy come from? Anybody with a scientific curiosity would have to say to themselves, you know, where does it come from? You know, where does the energy come from to push these two magnets away from each other? You know, to force this not willingness, this unwillingness to in any way be connected to each other. What is there? Where does the magnet make that stuff? And you can feel it as stuff. As you're pushing it together, you can feel it's just like there was some sort of stuff between there, and it's a little bit rubbery. It's like a piece of rubber. And I just can't push the magnets into the rubber without the rubber pushing back. There's something real there, not something virtual. Okay, and this, you know, this ability to fly across that gap, you know, where's the energy come from? Nothing gets hot, no fuel is burned, there's no radioactivity. You have to explain where it comes from, and the only place it can come from is the same place that gravity's coming from. There's a real forces in the universe, and they are really pushing on things, and that's the sensible, simple, reasonable answer. And physics has just completely dropped the ball. These conventional physicists have made a mess of it. They made a mess out of something that could be so simple. You know, all because they started just buying all these extraordinary explanations. Oh, space is bent, you know, and then the quantum mechanic woo, the electron splits into two electrons and it interferes with each other, themselves, its clone or whatever. I mean, just magical answers. And your skepticism there should be some bell that goes off in your head saying this can't be the right answer. Feynman mocks that, you know, because he concedes it's the logical reaction, but he mocks it as, oh, you're being superficial. You know, you're being trivial, you know, not to understand that, oh no, it doesn't, nature doesn't have to be rational or sensible, you know. No, it doesn't have to be. But there's every reason to believe it is. Okay, there's every single default logical reason to believe that there is a real explanation, that it is no real magic tricks. Okay, that none of this bullshit happens and it's just a coincidence that all the magic happens in the places we can't video. I mean, well, whatever. Like I said, all I can do is attempt to reason with you people. I mean, I don't know why you became atheists. I don't know why, you know, you sit here and pretend that you give a shit about logic, and yet you're so belligerently hostile to anybody who sits there and points out that this isn't very logical. The history that has gotten us to this point isn't a logical history. For 200 years, the Young analysis has been and was and is catastrophically wrong. And yet they keep citing it. as a foundation for their physics. And it's just wrong. It doesn't work. Just like Einstein's relativity creates stupid paradoxes that just make it unviable. Anyway. Yeah, so, but anyway, yeah, but to be treated so shabbily by people for questioning, and pointing out why there's good reason to doubt, and that there are rational explanations, they are possible. They claim that no particle theory can, and no this, and no, those are just claims they're making out of gas. There's no evidence that they've considered all the possible methods to create some sensible model. There's just no evidence that they have, that they can say that it can't be something else. Just like LIGO can't say we've recorded every possible sound the universe makes, and therefore we know that this must be a black hole crashing into a black hole. It's hubris, these claims. But anyway, so enough of video. And again, it's just unfortunate that there's no place to have this conversation. There's no one willing to have it. The intellectuals are just run away. I can offer $1,700 and get nothing. I mean, it's just amazing how shallow human intelligence is, as these people as example. I mean, they're not doing it very well. So, until the next time and such. I guess we'll go ahead and delete the morons comment. Jesus. All right. So, till the next time and such.